My dear, let us discuss the reduction of the spherical aberration, that how to reduce the spherical aberration. So now my dear, in the reduction, the very first point, first I have already told you that this is occurred due to large aperture. So the very first point to reduce it, take a mirror of small aperture. So by taking spherical mirror of small aperture. So spherical aberration is avoided by taking the spherical mirror of small aperture, and if you remember in my previous video, in my part 1 of spherical aberration video, I have drawn the diagram also of small aperture and I was avoiding by focusing at one point. Second is that, my dear, one more thing I wanted to tell you from my previous video. Here the refracted ray which are here, they are converging at two different focal points. Problem is that they should converge at one focal point. Problem is that not necessary that they should converge to the principal focus only, right? Earlier I was telling that that is principal focus, not necessary. The definition what it says, spherical aberration is an inability of spherical mirror of large aperture to focus or converge all the refracted ray at single point. Here the problem was that the all refracted ray are not focused at single point, they are focusing at two different points. Am I clear? So only the thing is that, my dear, it is a property of paraxial rays that they are converged to a principal focus. That is one which I have already observed. And marginal ray, because of the marginal ray, if they would have not there, the focus will be only at one point. But because of marginal rays, the focus caused at one more point, that is close to pole also. And this is occurred because of large aperture. So take care of that part by taking spherical mirror of small aperture. And second, by using stoppers. I have kept this diagram. My dear, what stoppers will do? Stopper, even if I take a large aperture, for example, say I have taken large aperture. So if I use here as a stopper, suppose like this, so all these rays will be stopped here only. You can see now, see. So this is the stopper you can use. So by using stoppers, we said. So what stoppers will do? Stoppers will cut off. It cut off marginal rays. So by using stoppers which cut off marginal rays, they don't allow the marginal ray to fall on the mirror, even if the mirror of large aperture. So first mirror is of small aperture must be taken. Otherwise, if it is a mirror of a large aperture, then you have to use a stopper, my dear. Stopper is the one which stop. Don't research under that. The one which stop, the one which cut off the marginal rays. And so that marginal ray will not fall on the mirror and they will not reflect and form another focal point. That is. And third is by using parabolic mirror. Please, this is very important, and then we will go for the use of parabolic mirror. By using parabolic mirror, look at the diagram. Now look at the diagram. Say I am drawing parabolic mirror here. This is parabolic mirror. Look at the way of drawing parabolic mirror. Parabolic mirror looks like this. And this is the pole. And this is the line which passed through the pole is the principal axis. Right? I have taken this as a concave parabolic mirror. Concave parabolic mirror. And this is the, my dear, the rays. I have drawn. Now my dear, in this case, look at it, this is a marginal ray, you can say. and this is the principal axis, and this is the paraxial rays, you can say. So this is paraxial rays and this is marginal rays. But here what will happen here? Here the marginal rays say reflect here at this point. Look at the diagram carefully. Similarly here also this reflect. This all will reflect and converge to one point at a single point. Say I name this as A dash. There is no spherical aberration now because all the reflected rays converge to a single point. Here it's the example, my dear. All, even marginal and paraxial, both are reflected to, after reflection they are converging to one single point. So this is the diagram of parabolic mirror. Reducing spherical aberration. So I hope you understood the topic. Now similarly, my dear, so here you can see parabolic mirrors are marginal and the paraxial, both after reflection converge to one single point. That was the problem earlier in the large aperture case, where in the spherical mirror cases of large aperture, where the reflected rays, all reflected rays of marginal as well as paraxials, they are not converging to one single point. There is two different points. One is near the pole and other is at principal focus. So this is only you supposed to learn, bache. I am trying my level best to understand the topic. Now next is, my dear, the important question with the board point of view, uses of parabolic mirror. And you should aware also, because the topic is like that, parabolic mirror. Beautiful uses. I am writing here, uses of parabolic mirror. Now what is the uses of parabolic mirror? My dear, we use concave parabolic mirror in dish antenna. In dish antenna, bache. In this antenna we are using concave parabolic mirror. Now you can think why. Sir, in dish antenna we are catching the microwave from the wider range. Microwave which are coming and falling on the dish, right? You can assume that they are so wider, they are coming from so long. So my dear, they will cause spherical aberration. And therefore to avoid that, we take in this antenna the concave parabolic mirror, like this one, the concave parabolic mirror, so that we can gather the microwave easily from the longer distance and we can avoid the defect of spherical aberration. Second very important use of concave parabolic mirror is, my dear, very important in astronomical telescope. Astronomical telescope, we use concave parabolic mirror to avoid again spherical aberration. To avoid spherical aberration. Again in telescope also, sir, we have to gather the light because we have to object as a planets. So you can imagine it is a so wider beam of light will be gathered on the mirror of the telescope. You can assume कितना दूर से light आएगा, कितने लंबे light होंगे, कितना marginal rays होंगे. Now of course it will cause spherical aberration, and therefore my dear, there also, to avoid spherical aberrations, that spherical aberration cause नहीं हो, we are using concave parabolic mirror. So जितने दूर से light को gathered करना है, my dear, वो सारे केसेस में यहाँ माइक्रोवेव गैदर्ड कर रहे हैं फ्रॉम लॉन्ग डिस्टेंस, अगेन स्फेरिकल अबेरेशन कॉज करेगा. यहाँ पर वी आर गैदरिंग द लाइट फ्रॉम द प्लैनेट्स, माय डियर, यू कैन अज्यूम, यू कैन अंडरस्टैंड. So again it cause a spherical aberrations, because spherical aberration बार बार cause होगा when we take marginal rays or wider beam of light falling on the mirror, causes the converging not on a single point, it causes the converging of the point at two different points, and it causes spherical aberrations. So to avoid such cases, my dear, we keep using concave parabolic mirror, so that marginal हो या paraxial हो, सब के सब after reflection should converge to one single point. Am I clear? So there also the spherical mirror of large aperture causes spherical aberrations, and to avoid that we use concave parabolic mirror. So even dish antenna, even astronomical telescope, and third, my dear, reverse also can possible. Look at it, one diagram here, one answer. My dear, suppose if I keep a source of light here, I am using a property. Say I use a source of light, I keep a source of light here. So say this is the principal focus. So of course na jahan converge honge, that will be the principal focus. No point, no issue. I have written at that is principal focus, because where it converges, because it's a rule that sir, a parallel beam of light always reflection and converge to a point called principal focus. So that's not wrong in saying at single point, that is nothing but a principal focus, but it is different for different mirror, right? Different for different mirror, depend upon their focal length. Okay, so now my dear, suppose here is a source of light I capped. Look at the reverse order, what will happen. If anything capped at the focus, so it will fall on the mirror like this. It will fall on the parabolic mirror like this, my dear. And here I cap the source of light. So now जहाँ रिफ्लेक्ट होके आ रहा था, अभी मैंने वहां से इंसिडेंट रे पास किया, एंड दिस इज योर प्रिंसिपल एक्सिस, यू कैन सी. सो नाउ व्हाट विल हैपन माय डियर, इट विल रिफ्लेक्टेड पैरेलली. जब रिफ्लेक्ट होगा तो दे विल गो पैरेलली. सो वंस अगेन व्हाट आई डिड, आई हैव रिवर्स द केस. नाउ आई कीप द सोर्स ऑफ लाइट एट प्रिंसिपल फोकस ऑफ द पैराबोलिक मिरर. आई रिपीट, आई केप्ट द सोर्स ऑफ लाइट एट द principal focus of the parabolic mirror, so that after reflection they move parallel to each other like this. You can see the reflected ray move parallel to each other to the longer distance. जैसे marginal से इधर आया था, वैसे ही अब ये marginal तक जाएगा, to the longer distance. And my dear, this is the method used in the torchlight. In the torchlight, in the headlights of vehicle, torchlight, because I wanted to spread the light to a longer distance. Try to understand. So what I did, sir, we keep the source of light at the principal focus of the parabolic mirror, concave parabolic mirror, right? I cap the source of light at the principal focus of the concave parabolic mirror. According to rule, after reflection they will move parallel. They will move to a longer distance, because they will reach up to, they will cause marginal also. They will move, जैसे marginal से they will come here, so they will, यहाँ से जब reflect होंगे तो they will go till longer distance, right? Reverse order I am taking. That because that is a rule in class 10th. Any ray parallel come to focus, from focus it go parallel. So from focus this light will go to the long distance, spread to the long distance, spread and form a marginals. And that is the phenomena used in torchlight and the headlights of vehicle. So that's all, my dear. This is the use of the concave parabolic mirror, you can say. The concave parabolic mirror using in dish antenna, and how you are using the microwaves are gathered from longer distance and they are converged to one point. Similarly, astronomical telescope also, we gathered the light from a longer distance and we make them to converge at one point by using concave parabolic mirror. And here the case is different, reverse, that we are keeping the source of light at the principal focus of the parabolic mirror, concave parabolic mirror, and then after reflection it will move parallel, am I clear, to a long distance. right? It will be spread over to the long distance. जैसे marginal इधर आ रहा था वैसे ये marginal बन जाएगा. Am I clear? And that phenomena is used for the torch light or the headlight of the vehicle, so that it will move to the long distance and we can see the object clearly. Thank you all and Jai Hind.